Right. Right. So the voice will be from here.
Yes, correct. What happened to your ambient light, bro?
This is the application, the StreamYard. StreamYard is doing that because I need to stream.
Okay, I think it's an ambient light. Okay. Yeah, it's an ambient light.
Because kind of
Okay.
I'm streaming now, giving me the sense of stream. Can we plug connect? Thank you. You are a nice girl. You are nice.
All right.
Okay, bro. Right there. We have. Let me unblock first. We are streaming, so it's okay.
So just left, right.
This is the agenda.
Right.
I'm gonna start giving a quick introduction to SRE. Then you take it over. You have another mic. You talk about bits. Then we give it to Natasha to speak about MoneyLion.
Oh, whose classroom is yours?
Then you will be the MC, taking the news corner. You call me to do the news corner. And then after I do the news corner, you take it to the next speaker. You call the next speaker. After the next speaker finish, the break. So people will pray, taking 15 minutes break.
Yeah.
After the 15 minutes break, we hiring and we continue with the show. So you take it over from here.
I see.
Okay, so after you introduce Duker, what is Duker, Meetup, and so on, you're gonna call Natasha for giving a quick introduction about MoneyLion.
For that. Oh yeah, you first, then me, then Natasha. Yeah,
Then
and
you will
we'll
be the
give
MC to call me like this one is the news corner. You call me, I'll do it.
All right.
Then after I finish, you call the next speaker and so on.
All right, got
So you
it.
take it over as the MC. You continue doing that.
Sure.
And when you come to feedback and Kahoot is Robin. Feedback is 0.
All right.
I really don't have to call me. Just show the
Yeah,
feedback.
just show the feedback. All right.
Can you guys share the screen?
Already shared.
I think.
Ready?
Already shared.
No, the streamer is
What happened?
shares. Share system audio today.
Yeah, it's on.
Okay.
Yeah, I think we're set, right? All good?
All good?
All right, sure.
We have 2 mics. Bro, sure is all good. I'll start first.
All right, you see first.
You keep this one with you.
All right.
Second one. Okay, so I'll give it to her. Okay, second one, you take this. This one has wire.
Yeah. So whoever's standing, you can use.
I will pass this to you after I finish.
See. All right. Let's. This one is.
When you mute, I'm mute yourself. Okay, good.
Yeah, all good.
All good.
Yeah, no problem, no worries. So,
Ready?
where do I stand to be the MC?
MC, be interactive, go around, make joke, eye contact with people.
I see.
After the speaker finished, do say something good like interesting, something like this.
Okay.
This is how
Okay.
the MC.
Interesting. All right,
A
gotcha.
fantastic, like
Fantastic,
fantastic,
wonderful.
fantastic, wonderful. Thank you.
Just be natural. All right, sure.
Be natural.
This one is off.
I thought it was on and then they can hear me.
Okay.
No worries. It's off.
Ready?
All right, then let's give it a go. Do I have to apologize since we're starting late? Do we need to apologize for starting late or something? Can they behind schedule?
Well, you need to start because it's already.
Yeah, we have to start.
We have to
All right,
start
yeah.
now.
Let's
You guys
start.
have to do it. Let's see.
So go. Okay.
All right, let's go.
Go.
Yep.
Ready?
Ready.
Hello. Hi guys. Hello. Hello. today is Wednesday. Wednesday is always tired, and I wake up today around 6 a.m. And from 6 a.m. I'm just doing call and work, Instagram, and any other thing, which is the life of SRE. Anybody SRE here? Yeah. One only. Lucky. You guys don't touch SRE because that's us. So yeah, today is Wednesday. Welcome to our meetup. This is the second meetup that we do this year, 2026. And we are collaborating this time with Duker. Big shout out for Duker. They do have many amazing things, and we are lucky to be part or partner with them to collaborate in that meetup. So a quick introduction about this, sorry, and then I will leave you guys with the MC, the main MC. Can we finish? Yeah, so we started SRE. We started SRE from community, like it's a kind of group of people. It's not only me. It was kind of 10 people. There's no company behind that, and we came up with SRE. Why? We saw like the SRE culture is missing in India and in this region. So we could start this meetup to collaborate with the understand what they need or what we have to share with them. Topics about SRE. Hopefully, someone got something from all of the topics of the last year. We actually, the first meetup for SRE was 2024, was in December 2024. So 1 year and 3 months. 1 year and 3 months. Every month is one meetup is a 15 meetup. 15 meetup multiplied with 2 is 30 talk. 30 talk. Amazing people shared it with you guys. Hopefully it was helpful. And yeah, we are here today. We are partner with Duker, with all of you supporting us. And that's the most important thing for SRE is to get the support from the community, from you guys to join, to do network with us. And you have any new ideas, we always open. So we always wanted to do something impactful. And we believe that we can do something impact because the lack that we have in Malaysia is every tool, every startup, every good innovation is coming from the West. So we want something to come from here, and we believe in you. We believe everybody here is capable to do impact. So if you have any idea, anything that you want to share with the community, with us, we are always open. We have a community WhatsApp group. So anything that you guys want to share with us. We can do something good together. As I said, hey, if you want to go fast, go alone. If you want to grow strong, go with the community. And we are here today with the community to grow strong. And hopefully we can see you guys doing amazing things. And we hope to do something impactful in the near future. Thank you. Passing it to the community.
Right, thanks, Zidane. That was a welcoming speech. Right, so hey everyone, my name is John. I'm part of Docker Kuala Lumpur. So a bit about Docker Kuala Lumpur. So we're based in Kuala Lumpur. We're part of the Docker team. So let me get down to what we consist of actually. So we're actually a community open to students, engineers, developers, and tech enthusiasts, which I'm sure everyone here is. So for the time being, we'll focus on learning containers, DevOps, and cloud-native practices. Basically, I bet it's one of your bread and butters. So this connects beginners, professionals, startups, and enterprises. It's welcome to everyone, be it if you're a new joiner, a starter, or you're a veteran. Everyone here is here for the same purpose. We share practical knowledge through thoughts, demands, demos, and real-world use cases. Basically, our mission here is to support local talent and open source collaboration. Since Hoque at its core is an open source platform, right? So just to reiterate, we're directly supported by Docker Incorporated. Right, without further ado, we'll begin this event. I'd like to pass the mic to our great sponsors, MoneyLion.
All right. Hello, everyone. Good evening. So, how is everyone doing? Need a bit more energy, guys. How is everyone doing? Good. Okay. Maybe you guys didn't feed you enough today, but it's okay. I hope your bellies are full and that you are excited to join the event today. So, if this is your first time, welcome to MoneyLion. This is our office here based in Kuala Lumpur. So we are actually a mobile banking and financial membership platform. We actually were established back in 2013, and we are currently serving the US market. So good news for us is that our tech team is actually based in KL. So this is our tech hub. We have all of our software engineers, data scientists, and other tech teams, of course, including the SRE team who is present here today. Okay, and one of our speakers will be giving his presentation later on this evening. So if you guys have any questions, if you want to know a little bit more about MoneyLion, me and my team will be seated at the booth over there. You can always stop by and ask us any questions you may have. Okay, we are always hiring for multiple roles, so if you or your friends are interested, do let us know. Okay, so without further ado, I'll pass it back to your host, John. Thank you.
Right. So, hey guys, thanks for coming again. Once again, I'd like to thank you guys for joining in regarding this event. It's great. Thanks to our great sponsors, MoneyLion, for sponsoring this event. So currently, I'm actually going to pass the mic to our SRE engineers. So from the SRE team, I welcome Zidane.
Hi guys, it's me again, I guess. So that's it quickly. Last month, actually, a lot of things happened. One of them is Open Telemetry Collector has been released with many features. Open Telemetry Collector, when they released two distributions together. The one is Open Telemetry Cool, which is the cool functionality of Open Telemetry, and Concept is the one that has a lot of exporters, a lot of receivers, a lot of processors. There are a couple of highlights I want to share here. Might be useful for you. One of them is the export traces to Google Cloud Storage. They started with log, but now you can export also the traces. The traces can go directly to GCS, which is cool. If you want long length and you have a big volume of traces, you can send it directly there for analysis and other things. The other thing is very cool as well, is the introduced the maximum trace size to be in the tail sampling. If you don't know the tail sampling is kind of you drop a lot of requests without sending them to the backend, and you have some policy to do the decision, right? But they introduced that maximum trace size bytes to drop immediately without putting into the memory, and then they take the decision based on the policy, because this is a big trace. We don't want it. We drop it to save the memory, and that's good, efficient for the memory. So that's a good as well. The third thing is something new is excluded namespace from Kubernetes watching. So the Kubernetes objectives receiver was actually getting everything from all the namespaces. Today they introduced something new, which is exclude namespaces. So the namespaces that you don't want to monitor them, you just exclude them, something like cube system or cube public and other things that you don't need. You can exclude them today. And yeah, so the Kubernetes release yesterday is a very minor patch release, which is v1.35.1. And there is nothing interesting there, but yeah, I recommend to go through them quickly. The Argo City. Argo City is one of the biggest releases with 546 feature and bug fixes and other things. It's very big, but it has a lot of good features. So I recommend to go through them one by one. You don't need to upgrade now, but you can just go through the breaking exchange to see if any valuable thing from the new features that you are looking for. But for me, we're gonna upgrade because there is a couple of features and bug fixes that we need. I recommend to go through that. Yeah, for other releases, there is a lot of releases, and you can tag them in Relix. Who know what is Relix? How many of you know what is Relix? What? Okay, I'll give you a quick demo. So Relix is actually, we are tracking 101 tools from the open source related to Kubernetes, related to the open source community, and we summarize in detail the release notes, so you can read the release notes and so on. But we recently introduced something that people need, which is actually many organizations have many of these tools. So I'll give you visibility about your tool. If your tool is out of date, it can upgrade it automatically for you and create a PR for you, pull request for you, and so on. So this is how it looks like. So for example, if the company, my company is Opsi, no one knows Opsi, but yeah, it's a company. And I can see here I connected to some of my repositories. It directly detects the tools that I use, and it summarized it for me here. So it's telling me, okay, you have these tools, you have a couple of outdated tools, and one of the most important things, you can go here directly and upgrade your tool to the latest version. So I'm currently now using version v0.11.144 from our intervention collector, but I can directly go and upgrade it. I choose the version that I want to upgrade because I only have one available above of me, so give me one. And then I can just create a PR, and the PR will be created for me. And then it will also send a notification on the Slack that this PR is created. You need to review it, so you can review and merge it, which is very cool. So the PR is here. See, open the PR. It's telling me like the changes, the file changes. If there is breaking a change or anything, it will highlight it. And also it upgrades all the collector for me from the different clusters. So you have automation, you can just merge it and do the pipeline for yourself. Everything will be fine. But we don't need to do it manually, so you can go to the setting here and, okay, I need to auto upgrade. So if any new feature comes, you can just, the PR was created automatically and it will come to your Slack, so you will get notification and then you can go and approve it and merge it. And also there is different upgrade strategy. If you want to upgrade minor automatically, or if you want to upgrade the all or the major and other things, which is very cool. Yeah, that's it. But the company's related feature in Linux. Other than that, you have like your feed, all the tools that you are following, all the features. It will be showing like this. Also, if we have written a blog summary for some of releases, it will be showing to you as well, and you will get notification, of course, to your email and your Slack to update you automatically when something new released. Yeah, that's it about Linux. I hope you guys find it useful. If not useful, we are always welcome for feedback. And back to the MC. Thank you so much.
All right, a round of applause. Right, thanks Dan for the latest news and updates. Right, without further ado, let's welcome Chee Lim Toh, the senior SRE here at MoneyLion. Right, guys.
Okay, hello everyone. Can you hear me? Okay, cool. Yeah. Okay. Yeah. So quick intro about myself. My name is Chee Lim. I'm a senior SRE here in MoneyLion. Today I'm going to talk about FinOps. I'm not too sure if any of you know about this term, but I hope after today's sharing, you can take at least one thing back which you may be able to use in your company. So just to start, fun fact, I actually did not know what I was going to talk about today. So I asked my new best friend, ChatGPT, what would be an interesting topic to talk about, and this is what I got. So if it's not interesting, don't blame me. Yeah, side note, I also write about DevOps, SRE stuff in my free time in my Medium blog. I will share a link later. If anyone's interested, feel free to take a look, and hopefully those contents help you as well. Yeah, so today, FYI, most of my sharing will be a bit more biased to AWS because that's what we mainly use. But I believe the concepts should be something similar which you can use in other cloud providers. Yeah. So just a quick run through of the agenda. There's 5 items. I just need to quickly explain to you what is FinOps and why FinOps. I'll talk to you a bit of my version of like the maturity ladder of where to start to where I think it's a good place to be, and how we can build the tools around FinOps to make it a platform in your company, and then some key takeaways you can bring back after today, and we can wrap up the short Q&A. Okay, so what's FinOps and why? So there's a lot of definitions of FinOps out there. I'm not going to read to you the long sentence from Microsoft. I'll just give you a short TLDR. What is FinOps? This is my version. It's basically like a practice that enhance your visibility into your cloud spending so that you can make a better judgment based on understanding of where the money is going, right? What you're paying for. Yeah, that's my version of a short version of FinOps. So why FinOps? These are just some common scenarios which you may be able to relate. So maybe you join a company, your ship things fast, build stuff, build infra, spin up lots of resources, and then you come to a point where you don't know what resources you actually have running, and then the cloud bills gets messy real fast. You start paying for a big bill, but you don't know what you're paying for. You just know you're paying for RDS databases, but what databases actually running, you're not sure. And then let's say you're using a shared platform, like for example, a shared cluster, and then you have multiple teams, multiple tenants running the same cluster. You don't really know who is using the most in your cluster, and you don't know how to actually build them, right? And then let's say it's try to start filtering. Okay, for example, if you tag some of resources, right? And then you go to, let's say, Cost Explorer, and then you try to search a filter based on the certain tag. But you notice that most of your resources does not match that tag, and you have no idea what exactly those resources you're paying for. And then you try to cost optimize, but you don't know what exactly to optimize, right? Because you have no visibility of what resources you have, right? And then let's say you try to budget for the bill next year, but you don't really know how to budget because you're not really sure what exactly you're spending for, other than the general idea of the AWS resources that you're using. So this is my version of the maturity ladder, I would say. I try my best to generate something from ChatGPT. This is the best I can get. Yeah, so basically, I would say start with the visibility, right? You want to know what exactly you have in the organization, right? You want to know what resources you have, who does it belong to, and then that's where the ownership comes into place, right? Who owns those resources, right? And then once you go into there, have some guardrails, right, to ensure those tags that you have added actually are in place. So it doesn't, whatever you have tagged doesn't get removed, and whatever you have set in place doesn't, how to say, break when you continue to add more resources. And then later, once you have everything done from the bottom, you can start to do fun things like automation, which I'll share some examples of what we did here, of how we automate some things to actually save some costs. And then if you want to bring it to the next level, you can do some self-service automation of how you can allow engineers to self-service to spin up infrastructure, and then delete it, let's say, once it's done. And yeah, AI, this day and age, it's a bit hard not to talk about AI, but I'll say that comes in a bit later. We start with first like the visibility, right? So yeah, okay. So yeah, FinOps. Let's start with the first point, right? The visibility and guardrails, right? So I would say like try to like ask this question and see if you have the answers. Like, do you know what resources do you actually have in your accounts? Who owns those resources? Is it owned by a specific person, a team, a project? Which environment is these resources for? Is it for dev? Is it for production? Is it for staging? How was it created? Was it done through IAC tool like Terraform or CloudFormation or whatever? Was it done through the console? Was it created through some automation tool? If you have those answers, then I'll say good job. You probably have a good idea of what you are paying for, right? And let's say you don't have those tags, right? You can, I'll suggest you start with a frame of knowing what's the best paying strategy you have, or you want in your company, right? So some say you have a name for the resource. I think you can look at the starter tags. Like these are some recommendations you can start with. If you don't know how to tag your resource, you want to give the name. Is it belong to a team? Is it under a specific project or business unit? Which environment does the resource belong to? It's managed by what, right? And then let's say you're doing multi-cloud. Sure, feel free to add a cloud tag as well. Yeah. Then once you have decided on the tagging guidelines, I say that you want, that's when you start taking deep. You can write a script, maybe filter through all your resources, find which resources don't have those tags. If you spun up those resources using your infrastructure tool like Terraform, add those tags into your modules, make sure it's propagated to all resources. Try your best to basically tag every single thing, right? And then go through and you can start to basically reduce until you find your no tag key won't show a big amount because you have tagged most everything, right? And then if you are using AWS and you added custom tags, make sure to enable it in the AWS cost allocation tags, because if you don't enable it, you won't be able to see it in your Cost Explorer dashboard as well as your billing reports. So make sure to enable that on your accounts. Yeah. So yeah, then just investigate which resources are tagged, tag them all, write a script, do whatever, right? And then repeat, verify until you get everything done. And then, yeah, your guardrails. So you can use a few ways to ensure that this guideline sticks. You can use SCPs, but I would say be a bit careful because it might cause some disruption if your SCPs are too strict. You might end up having resources that can't be spun up for one reason. So I'll say test and be extra careful. You can use Terraform validations. You can use any OPA. It's up to you. Your goal is to ensure that those resources that gets created have those tags. So yeah. So fun fact, while we were actually diving through this, we found out that those automatic snapshots that gets created based on your backup policy actually does not get the tags on your cluster. Let's say if you tag your database, your clusters, those snapshots don't have those tags. So you see a bunch of snapshots that are not tagged, and those will fall under the no tag key when you filter those in Conf Explorer. Similar to your auto-scale instance. So if you use RDS and your auto-scale instance, your auto-scale instance also does not have those tags. So you see a bunch of tags. Most of the instances, they're untagged, and you don't know who do you build these instances to. So I think quite recently, if you are using Terraform, snapshots, you can just pass in this variable, copy text to snapshot, false, just set it true. So once your snapshots gets created, it gets the tags as well. But manual snapshots, if you do not add a tag, then obviously those tags won't be present. What we did here is that we actually built a Lambda to listen to events for snapshots getting created and instances getting created. We actually automatically copy the tag from the cluster and put it to those snapshots and instances. So that ensures that all snapshots and instances also get those tags. So it helps in our FinOps reporting down the line. Yeah. So yeah, the fun part. How do you cost optimize? How do you save costs? I think once you tackled the visibility problem, you know what you're paying for. That's when you can start really drilling down to how to cost optimize, right? These are not all the ideas, but just giving you some ideas. So yeah, the no-brainer, clean up your idle resources, and like once you do your tagging, you're probably gonna find out you have a lot of resources that are just sitting there idle for God knows how long. So those manual snapshots, those don't get created automatically. You gotta manually clean those up. If you created many of those, your EBS volumes, those that are unattached, go through them, delete those EIPs not used, delete those. Go through all your idle resources, start cleaning those up. Yeah, don't leave it hanging around, right? And then right sizing, right? You want to right resources. You might be over provisioning some of those databases or EC2s. So right sizing is one of the ways to save costs. Yeah, lifecycle policies, use S3 lifecycle policies. You can use TTLs in your databases. Up to you. Yeah, network data transfer costs. Avoid going through a net gateway as much as possible. Try to stay in the internal AWS network if you are using AWS. Use VPC endpoints for connecting to S3 and MongoDB. It's free, so just use it. Save some cost there as well. And then scaling, right? Try to auto scale your resources. Like RDS, there is the feature where it supports auto scaling by CPU and database connections. But if you're using DocumentDB, it's not supported as of today. But because of that, we actually built our own DocumentDB autoscaler as well. So if you're interested, there's a blog about it. You should read up later. Yeah. So yeah, here's part for your interruptible workloads. Yeah, discount plans, reserve instances and settings plans. Once you already know what resources that you have and gonna keep long term, leverage that, get some discounts from your cloud provider, right? And I'm not sure if you all have heard, as of last year, December, AWS announced database savings plan. So you can actually leverage that as well to get some discounts on your data. Reserve instances is too strict for you. And it also supports DocumentDB, by the way, if you are using DocumentDB. But fun fact, as of today, they announced DocumentDB version 8, but it doesn't support the R8G instance. But in order to get the database saving discount, you need to use G. So you want this version, so it's up to you to decide on that. And I'll say serverless, it's really up to you. I would say it could be a double-edged sword because sometimes you just use everything serverless and you're not paying attention to resources, and then you just spin up resources and end up paying more. So I'll say just be careful if you're using serverless as a strategy to save costs. So yeah. This is just a quick comparison of Syntime and RI. I'm not AWS ambassador, so I'm not going to talk about the stuff that they have, but I'll just say that it's really based on what you think is better for you. Savings plans gives more flexibility, but less discount. RI gives more discount, but less flexibility. So you can decide what is best for your workloads. Yeah, database influence. Oh yeah, by the way, I checked Malaysia region is supported. So if your workloads are in Malaysia, you can also use this. Yeah. Oh, one more thing. They only support instances above version 7. So not all instances are eligible for this savings plan. You got to check first. Don't just assume that your workloads actually is supported in this savings plan criteria. So yeah. So when I say IDP, I'm not talking about identity provider. My definition, or at least this definition of IDP is called an internal developer platform, something that we built here for our engineers to self-service certain things. So what we did was that we built our own internal developer platform. We centralized everything here. We let we add visualizability to actually allow engineers to see which of their databases are over provision, under provision, or even sitting idle. So a quick metric I would say is that if you see your databases has an idle connection database connection of 0 for maybe more than 2 to 3 weeks, it's probably a good candidate that those databases aren't used at all. So expose those data to your IDP, then flag them, right? Ask them why is there a databases sitting there costing money, not getting cleaned up, right? And then let's say your bosses want a report of your cloud spending, who's paying for what, which teams spends the most. You can have those data in your IDP as well, able to export to CSV, whatever, right? And then yeah, go from there and then try to target what is costing you the most. Or say most of the time it's usually your databases that will cost you the most. So you can start targeting there how to save cost there, which is most probably cleaning up your idle databases and right sizing your databases. So yeah. So I can't share with you the exact developer platform that you have, but I try to get ChatGPT to generate something like this to give you an idea of how it might look like. You can design it to however you want, but it's just some inspiration or idea of how it could look like, right? Having everything into one place and having engineers to come to this place to get all the info that they need. Yeah, so for example, for a FinOps report, you can generate monthly to know which team A is spending how much for what, team B is spending how much for what. So at least it gives a bit of ownership of the teams that they will manage their own costs. You don't need to keep chasing them to or clean up their databases that are not used. Okay, yeah, some automation, right? So once you have actually tagged all your stuff, you know who owns the stuff, you can also add some automation to further optimize the cost, right? So a simple idea of what you did is that you know that maybe there are times when you need to do some load testing. So you need to scale up your database for, let's say, 2 hours, for example, right? And then you scale it back down after your load testing is done. So most of the time, maybe that's manual. Someone does do it manually, scale up, do your load test, go and dinner, forget about it, and then this stays at those whatever big size of database that you scale up to for days, right? So those are wastage of cost that could be actually fixed by some automation. So building automation to actually help to automatically scale up the database, then scale back down after, let's say, X hours of based on what the engineer decided to select, right? And that can be also integrated into your internal developer platform, which you have built if you have one, right? You can also do some automation to clean up those resources. So, for example, you have like a sandbox account that you have in your company. You can set some rules based on your tags, right, to automatically clean up the resources after a certain period of time. You can also generate those reports automatically. Go to the IDP and click some buttons because all those data is there already. And yeah. So just ask GPT to generate some diagrams of this Lambda cleaning out all your AWS resources automatically. This is a Lambda trying to tag your resources automatically. Basically, what I've shared to you is things that we've already done, and we really see that it actually helps. So I'm not just telling you stuff out of thin air. It's actually things that we've done and we find it helpful. So yeah, if you're using Kubernetes, there are some ways to optimize the cost as well. I'm not going to talk about KDA and Carpenter, but these are just some ideas that you can use in your cluster to, let's say for KDA, it's a more advanced autoscaler. You can scale non-production workloads to 0. Let's say when there's no traffic, for certain periods, scale down to 0. If there's traffic, scale back up. That could help you save some costs. Carpenter, right? A more advanced node autoscaler, it can actually help you use Spot easier because it has a way to prioritize to use Spot workloads, and then if there's not enough Spot, fall back to on-demand, right? That could help you save some cost as well. So one thing I will say is a gotcha moment to us that if you have abused the do not disrupt annotation too much, you might end up having too many nodes that are stuck there idle, unused, and you could end up actually spending more money rather than thinking that, oh, Carpenter will help me save cost, right? So I'll say use it very carefully. Do not just simply add it everywhere. And yeah, Carpenter supports consolidation policies, allow you to impact your nodes better. You can look into that. And also, I'll say look into your node class. I know it's a good idea to add all the instance classes available in the cloud to Carpenter, but what we realize is that, for example, your workloads are more memory intensive, but Carpenter chooses, I would say, the cheapest node available. For example, the C instance node is the cheaper one. So it's still a C node, but it only supports, let's say, 2 core CPU and 4 gigs of RAM. And then your workload goes in, and then another pod creates, another pod also requires the same thing. It cannot fit into the node. Then it creates another C node for the pod. So end up you have 2 nodes which are used half, or maybe 3/4, right? So I would say Carpenter doesn't solve all your problems. Make sure to actually check how much of idle wastage your node has. You can use a tool, which I'll share later, of how you can actually dive deep and see how much of idle usage that your node has. Yeah, so other tools you can use kubectl, superctl, VPA, or whatever, right? So yeah, okay. So one more thing, if you want to actually dive deep to know how, if you have a shared cluster and everyone's in the same cluster, and you want to know which team actually is spending the most, right? Because they have a lot of resources in the cluster. What we did is actually we use kubectl, the free version. If on AWS, you can use the EKS optimized bundle. Because the free kubectl has the limitation of 250 cores, right? But this one actually allows you to go above the limit. So you're not bounded by the 250 cores CPU limit. But there is the 15 days retention span limit. But we found a loophole again around it. So if you want to know more about it, you can talk to me later. But I won't talk about it right here. So yeah. So this is a tool that we use. I found it quite helpful. It's called EKS Node Viewer. It's from AWS. It actually allows you to really see how much of idle node available in your EKS cluster. So like the top one, you can see a lot of like gray space, right? Those are not used. It's just sitting idle, right? And the goal is to make sure that your node is really being tagged and used as much as possible, so that way you're not wasting any you're not wasting costs. Yeah. So if you cannot use it, I'll suggest try this out. And if you're a big fan of open source, there's this free open source FinOps dashboard tool out there. Yeah, feel free to use it, but we have not used it. So yeah, AI. I feel it's a bit hard to not talk about AI at this day and age. So I'll just talk a bit about this. You can use AI to supplement your FinOps visibility. What we did is that we actually did an AI agent. We add it on top of our IDP to allow engineers or any product managers or anyone basically to ask the agent based on natural language, why is my resources costing this much? Deep dive into it, or how to optimize the cost, right? It's you can use it to actually further understand the cost in your accounts using AI, right? Rather than going through the dashboards. You can also use it to generate more fancy alerts or reports. But yeah, these are just some ideas I guess you can use AI for. So yeah, so some of the common pitfalls that you may face when you start this journey, you might start to optimize too fast before actually knowing what you are trying to optimize for, and that could cause some disruptions. You try to, you need to have, I think it's not something you can do by yourself. You need collaboration with the right stakeholders. So you gotta get a buy-in to do this, else you're just gonna be the one chasing people all the time. You try to over-optimize too early, and you might end up causing some production incidents, for example. Adding too many guidelines too quickly. Let's say your SCP could block your auto-scaler for creating new instances, right? Because it doesn't abide to the SCP policy that you added. And let's say you add allow AI to run everything, who knows? You might try to optimize costs, drop the database, who knows, right? So yeah. Oh, one more thing, this is not a one-time project. FinOps is something that you continue have to do continuously. If you think it's a one-up project, you will end up getting to the state that you want now, and then 6 months later, you might be back to square one again. So yeah, some key takeaways. I'll say the most important thing is the visibility, the foundational piece, knowing what you have, who owns it. It's all about tagging and labels. So adding those tags and labels to your resources. Yeah, having guardrails so you don't keep nagging people to add those tags to those resources. Don't try to automate everything quickly. I'll say do it as much as you can that's suitable to your company, right? And try to make things self-service. If you have IDP, allow the engineers to go to IDP and run those automations there, rather than having them to always pull your script and do those things manually. And yeah, don't stop. Always re-evaluate where you are and how you can improve further. So yeah, I'm not sure if you're gonna have my slides, but I put all the links here. So if you do, there are all links that I've talked about. That's all here. Yeah. Yeah, Q&A. No questions? Great. If anyone has actually done something similar of doing a FinOps initiative in your company, I'll be interested to know about how or what you did. So yeah, like feel free to reach out to me through LinkedIn or after this talk. I'll also need to discuss certain things. I know the talk's a bit more general. I didn't go too technical because I'm not going to share our secret sauce. So if you want to know more technical, you can talk to me after the talk. Yeah. So no questions, then yeah. Thanks.
Okay, sorry.
All right, thanks for the speaker here.
That's fine.
Toh. Another round of applause for our speaker, Chee Lim Toh. All right, guys. Now we're going a 15-minute break. Feel free to grab some drinks while we're trying to prepare for the next session and our next speaker.
You mentioned that it's prayer time. Hi guys, we still have one more session of rested session. I'll have quiz, Kahoot quiz. The winner will take some very good Duker swags, and we have also 1 year subscription for any product here from JetBrains. And one lucky winner can get Realnex for free for 1 year. So stay tuned. We have a lot of things. You don't need that. Huh?
What for 1 year? What was the second prize?
JetBrains. What are the Realnex? Realnex subscription for 1 year for free. This is the one that I showed to you. So stay tuned. We have a lot of things. For our Muslim brothers, if you want to pray, we have prayer rooms there. So please go on the break, do your duty. I will come back in 5 minutes, 15 minutes. Thank you.
I mean, I know my boss there. For some, yes, oh yeah. But can I still have In order to make a spiritual right, you pay for the price. You just pay a lump sum. You don't and you can use that search time. It's only then we can do that. I thought you guys we didn't say fantastic. Breakfast.
This point I love this. I think they double try. One you can find slides. You need to set up these slides.
Is he mine?
There's only 3 minutes left.
3 minutes left.
For the
You
break.
can set up your stuff first.
Yeah.
Reference.
I don't know. I mean,
You can do anything also.
this is live.
Yeah. Okay.
So
Hold on. You want to do the entire screen? Can?
his. Oh, okay. That's the live.
Okay, so you can share? Oh yeah, you're already sharing. My moon. Okay.
This is right.
Yeah, you can see.
But,
Did
oh,
you
they
turn on
don't. They
yeah, they
don't.
don't have that. Did you turn on your mic?
Oh shit! I have mouse actually. Should I connect my mouse and then
Did you turn on your mic?
my mic?
Okay.
Yeah,
fine, okay.
I
If
am.
you have a mouse, it would be great.
Yeah, I have mouse. Should I bring mouse?
Yeah.
It's fine.
Else you have to either you want to go there. I think it's better.
You guys have any controller? No. Like to change the slides?
That's why I get stuck just now.
Okay.
That's why I get stuck just now, buddy.
Okay.
But
Okay.
are you ready?
Yeah, I'm ready, but I need to interact with them. How can I interact?
Right, guys, we're almost ready for our next speaker.
Yeah, no worries. That's why I got stuck just now.
Oh, okay. So start. You can.
Right, welcome back, everyone. Right. Now we're going to start with our next new speaker. Everyone, give a round of applause to Shuvo.
Thanks, everyone. If you guys can just come a bit closer, it would be easy for me to, Okay, no worries, guys. Okay. Thanks to SRE and Docker for arranging this month's meetup together. I'm one of the volunteers of the SRE meetup. If you guys have seen me out there for the previous meetups. And so today, this is the topic that I'm going to talk about. Just before I'm going to talk about how many of you guys are actively developing AI agents or working with AI agents. Okay, cool. Yeah, quite a few. Nice. Okay, so the agenda for today's topic is we will talk about the observability of the agent in production. How we monitor our AI agents and why we have to monitor and what is the difference of the observability of the AI agents compared to our traditional observability or our traditional software, right? That's the agenda. At the end, I'll show you guys a demo with Line Suite. It's a tool where you can send your process for your AI agents, and then you can evaluate your AI agents performance over there. So, if you guys know me, if you know, then you know me. Otherwise, I'm Shuvo. You guys can call me Shuvo. I'm lead DevOps engineer at Restaurant. So, for your information, is there are four building blocks for AI agent. So there are four layers, right? Let's call it blocks: perception, reasoning, memory, and action. So perception is the agent's sense. When we ask the agent or we tell something to the agent, it first thinks what is actually the user wants. Okay, so it sends your query, and then the reasoning part is where is the decision it takes. Decision happens. It decides. Okay, what are the steps I have to take to complete the task, or to get the information, or to call the tools, whatever they will see. Action is, what it means, like it takes action, it executes the steps that it already decided. And memory and feedback loop is where the short-term or the long-term memory actually resides. So if you want your AI agent to, have your hello. So if you want your AI agent to be more dynamic and to have your previous conversation as a context or previous interaction as a context, you can go for short-term memory or long-term memory based on your use cases. So this is what the building blocks of AI is. You give one input, you trigger the agent. This is the reasoning layer where agents go to LLM to do the part. And then this is the action layer where it can call the tools, it calls APIs, and then it takes the action. So the action can be calling these tools, and then the output is it will either complete the task or fail, or it hands over the task to another agent. Now the question is where the agents fail, right? So there are two levels. One is end-to-end level, and one is component level. So end-to-end level is you ask a question to an agent, or you give a task to an agent, and it fails, or it doesn't give you the correct answer. That's the end-to-end level, input and output. So, and component level is whatever the steps it takes between this input and output, each of the steps are component. Calling the LLM, calling the tools, everything is component. So, fail to complete a task, an end-to-end failure. It can't give you the output. It's like an infinite loop of reasoning. It's an end-to-end failure. Calling tools with incorrect parameters, it's not end-to-end failure because you are calling a tool to perform a specific step. So it's a component level failure. Faulty hands-off to other agents is also one of the steps, so it's a component level failure. Tools not used, but LLM failed that it was called. It's one of the, it's also a component level failure. Now, the observability for AI agents is not actually software observability that we do nowadays, right? Traditional software is deterministic. You know, this will be the output. If for input A, I have input B. I have output B. That's, you can determine the output based on your code logic. Your code is your source of truth. And when something breaks, you check the logs, you check the traces, you go and you check your code, you identify what's the bug, right? But for AI agents, it's not that deterministic. It's agents don't just answer. It reasons, tools, and loops until they decide the task is done. And we don't code the steps for the AI agent. We prompt the goal. So you give instruction to your AI agent. Now it's up to your AI agent to reason those steps and take actions based on your instruction. So you can't 100% be sure that AI agents is actually following your instructions or not. It can hallucinate, right? Because it's like, you think of your human brain. You give instruction to someone, they can mistake, right? They can make mistakes. So this is that's why we say that the code is not source of truth for AI agents. There is an extra layer, and that's why you can predict the exact path the AI agent takes until it actually runs. But when you develop your AI agent, you can evaluate based on some example questions and compare with your expected outputs. But you may ask one question in one way. The other user, there are thousands of users who can ask the same questions in thousands of ways. So it's variable. Input is, it's variable. Output is also variable. That's why it's very uncertain. Now, if something goes wrong for AI agents, right? You are not finding a single line of code that fails, not like our regular software. You ask these questions like, why did agent decide to take this tool instead of that tool, right? Are the context from the knowledge sources aligned with the user questions? You ask your agent, okay, I need the pricing details. Now your agent goes to your privacy policy and gives you the update of your privacy policy. So why? Why it is doing that? Maybe something is wrong with the prompt, with the instructions. Then is my agent hallucinating to answer throughout the 20 steps? Let's say you give so much instructions to your AI agent that your AI agent actually messed up with those instructions. Your prompt is not good. And the context is that huge that it's not optimized in such a way that it cannot give you the proper answer, it hallucinates. So sometimes it gets context from a knowledge source, and sometimes it gives you some facts, like sky is blue. Now if I ask AI agent, why my sky is orange? And if it says something like, okay, sky is orange because your document is saying sky is orange, right? But sky is not orange, it's blue. So there's this type of confusion, like how the AI agent actually hallucinating or how it is taking those steps to perform those tasks. You need to justify those reasons. That's why we're not debugging the code, we're debugging the reason. That's the difference between the AI observability versus our traditional software observability. So you still write code to define your AI agent, like the tools and then which data it needs to extract. You write prompts and tool descriptions to guide the agent's behavior, but you won't know how the LLM will interpret instructions until you run. So that's why the source of truth, it shifts from code to traces. That shows that agent actually did this task. This is the reasoning behind this step. It caused these tools to give me this output. From RAG systems, it retrieves these documents, and based on these documents, it gives me this answer. So these are your source of truth. Your production traces are your source of truth. And now the agent evaluation is not similar to software evaluation. So for traditional software, what we do is we write unit tests, we write application tests, end-to-end tests, right? And all our business logic, everything is in our code. Code is source of truth. So your tests, it executes, it finds the logic, it gets the output, and it gives you a, like, okay, it's correct or it's not correct. But for agents, you're not evaluating, you're not testing the codes, you're testing the reasoning. So the reasoning capabilities, we have to test here. The code works that you write for your AI agents for taking the actions, but did the LLM model make a smart choice or not based on your instructions? That's where we need to evaluate it. So there are a few evaluation techniques. Langsmith is one of the tools where you can send your AI agent traces. You can use this tool to instrument your AI agents to send the production traces. And you can do evaluation over there as well. So these are the few techniques. One is human. Human is like human manually gonna evaluate the traces. Okay, AI agent give this input. User give this input, and AI agent give this output. Is it correct or not? Then code is something like it's deterministic. It's like we use structure, right? A lot of us have used structure for Gemini, for ChatGPT, right? So let's take an example of cursor. So you ask cursor, okay, for this code, we'll fix this code. Fix this code. So it gives you an output, not in a summary. It gives you the real code, right? So this type of technique, they use it to check whether the agent response actually follows that defined schema or defined pattern. You want a JSON output from your agent, but agent is not giving you a response in JSON. It gives you maybe in what by email, or maybe the JSON, the object is not correct, the way the object should be. So that's where we use code, custom code. LLM as a judge is you use another LLM to evaluate or to judge your AI agent. At least one LLM is judging another LLM's performance. Like the way we do, one human is judging another human. And pairwise is kind of, we do A/B testing for our software, right? So suppose you're using now GPT-5, let's say GPT-5 model you're using for your AI agents. Now you want to upgrade it to GPT 5.1. So that's where we use it. So we evaluate for this model, model A, and then we evaluate for model B, and then we see what are the difference. My agent is performing the same way we expect or not, it degrades or not. That's the technique pairwise. Now there are two types of evaluation. One is offline, one is online. So offline evaluation is for benchmarking, regression testing, unit testing, and back testing. So it's for pre-deployment. How it works? You come up with some reference question. Let's say you have a chatbot, you have a support agent. So you can based on your company information, you come up with 100 questions. That these 100 questions you can ask your AI agents. This is kind of a sample question, and you know that these are the expected answers for these questions. You want your AI agent to answer these expected answers. Then you run that set of questions against your AI agent. Now your AI agents give you outputs, right? Based on the inputs, based on the questions. Then you compare. So what you are comparing? The expected output versus the agent's actual output. That's offline evaluation. And then if you see that the comparison is good, that means your agent is actually giving you expected output. So we do this offline evaluation before we go to production. Online evaluation is after we go to the production, for the production model. So it's real time, it's for anomaly detection, and it's for production feedback. So how it works? Instrument your AI agent. When your AI agent runs, it sends the traces to the platform, to the Linesmith, and then from the traces you see, okay, my AI agent is actually performing good or bad. Is it answering correctly or is not answering incorrectly? So let's just see that what are the components of the traces. So runs, there are three primitives: runs, traces, and threads. It's not similar to the current observability stack that we use for our traditional systems, right? So runs is kind of span we use in our normal traces. It's like a single execution step. One example is, suppose one LLM call will put an output. You ask a question, hey, how are you? Agent replies, hi, I'm good, how about you? So the agent sends hi, how are you to LLM, and the LLM interprets, the agent is asking you with greetings. And then it replies that, hey, I'm good, how about you? So these are the things, this is a single call, it's single execution. Traces is the complete agent execution. To complete a task, the agent needs to take, let's say, 20 steps. So all the details of those 20 steps, all together we call it traces. And threads is multi-turn conversation grouping, multiple threads over the time. It means your agents did 3 tasks. Each of the tasks take 10 to 20 steps. If I combine all the tasks together, then it's a thread. You can let's take an example of chat agent. So user is talking with an agent, like customer support. So I'm one user, and I'm talking with that customer support agent. We are having a lot of conversations, right? All the conversations I group together. That's a thread. This is the ideology here. Let me give you some example. So runs is this. This is the full trace. Chat OpenAI means it's one LLM. So this is run. Conduct research, it's a tool. So research, graph, generate queries, chat OpenAI, these are all runs. And all together, we call it a trace. And thread is, okay, let me explain a bit more. So turn is one human query, one agent response. That's one turn. If there are multiple queries and multiple responses from the agent, and you together, that's a thread. So it's one single turn, and you see there are 3 turns. All together, it's a thread. So thread is capturing multiple turns of conversations. So the demo today will be how we should evaluate a RAG agent with LLM as a judge. There are multiple techniques I mentioned before. It's not possible to share everything in this call. So I just take one thing, LLM as a judge, because right now everyone in the industry, they are preferring LLM as a judge to evaluate their AI agents because it's easy. You don't need human to go to every trace and change. and evaluate every traces. It's not possible. Second is human. If you assign one person from your team, okay, I need to evaluate all the traces in production. I need to see. Your judgment will not be same throughout the traces, right? But LLM as a judge is scalable. If you have, let's say, 10,000 traces coming in every day, right? One human cannot judge every one of them. It takes a lot of time. It's not a scalable solution. But LLM as a judge, it's an automation. You just set this, you give instructions. The instructions is same throughout all the 10,000 traces. So the evaluation is a LLM as evaluation. It gives a standard idea of what's happening. And this is there is a company named Toolens. They came up with this framework to evaluate a RAG agent. Now there are three components. One is quick, like you are asking question to your AI agent. Then there is context. Context is your data store where your documents are. So when you ask user the question, your AI agent is going to your database and retrieve your context, retrieves the data, and then it gives you a response. So there are query, there are context, and there are response, right? So that data store I'm talking about vector database. Okay. Now there are three metrics we need to evaluate. One is answer relevance. It's end-to-end. Means is my response, right? My response is agent's response. Is agent's response relevant to the user query or not? The question I ask to agent, actually he is giving me the answer related to this or no. This is the metric answer relevance. Second is context relevance. The question that user asks and the agent retrieve the context to answer. These contexts are relevant to that user query or not. This is context relevance. And then groundedness is this context that it retrieved to give this response. So this response is actually supported by that context or not. Now, why we need answer relevance? To check whether my agent is actually giving me right answer or not, right? Context relevance to see that whether my RAG system is working perfectly or not. If the context is wrong, so the agent will give me wrong answer. That's why I need to check whether my context is actually relevant or not. Groundedness is like a truth. The response that it generates, is it actually related to the context that I retrieved or not? Is it actually coming from my knowledge base or not? Let's say I have asked an agent that, do you know what's the plan for, let's say, what's the plan? Let's say I am a company, let's say for my company, Respond.io, we have several plans. I asked my agents, can you tell me about the plans, monthly plans? It can search Google, right? It can go to Google, it can fetch from there. But I gave him a PDF of the details of my company's plan. So it should go to my vector DB on my instruction and fetch the information what I have in my PDF in my vector DB. And it should answer me based on that. If it answers extra, that means it's either hallucinating or my agent is not working perfectly. If it answers less, that means something is wrong there. It's not following my context. So that's how we should evaluate a RAG with an LLM as a judge. Now for the demo, let me show you. I just wrote a custom agent, and let's say, okay. It's just for demo, so you guys probably will see some documents name here. Yeah, it's not for production. So this is the answer that it gives you, right? So from the response, you see that it says that the premium plan is priced at $99 per month, blah blah blah, this stuff. And then additionally, we also offer a 30-day money-back guarantee. So it used these three documents from my vector DB: pricing, refund policy, and privacy policy. Now I need to check whether when I asked this question, can you share about pricing, and how he gave this answer, it looks like it's correct. So, but it's not possible for me to check that in production, that all my users are getting correct answer or not. Now let's go to my, this is the platform Langsmith. So you set a project, and then in the project you will get the traces for your every agent execution. Okay, so this is one run. In the run, I have these inputs. This is my router input. Okay, before that, let me just give you an insight. The pattern was I have an orchestrator agent, and then I have mini agents. So the orchestrator agent, based on the user query, based on this user query, it routes the request to different mini agents. If I'm asking about some information, it should go to knowledge. It should go to the knowledge source mini agent. If I ask for, let's say, update anything of my database or get this particular customer information, it should go to the tool that is calling the database. So based on my query, the orchestrator agent routes to different mini agents. So based on this, it routes to, it should route to knowledge search, to the knowledge retrieval mini agent. Then I have session ID, I have synthesis prompt. So synthesis prompt is to, when I get the response, when my agent gets the response, it should synthesize the response. And this is the user query, what I have asked just now. This is the response that it gives me, right? This response. Now I'm also sending some metadata. So this is the part where my agent is doing this, deciding what I have asked and what he should do. So this is the reasoning part, that the user is asking for information about pricing, which falls under product info and general question. Then it routes to knowledge search, and then these are the, I'm also sending some metadata, which are the documents that I retrieved from my VectorDB. So now I have the input, I have the agent's output, and I have the relative context, right? For this run. And this is the whole traces. This is the particular LLM code, where you see this is the query I have asked. This was my system prompt for that LLM call, and this is the output. And based on that, it routes that request to the knowledge mini agent. So knowledge mini agent, this was my original query. This was the refined query. And based on the refined query, it fetched this context from the VectorDB. And then later, when it has this content, it asks the LLM to generate that final answer. And this is the final output from my agent. So this is how the trace works. Every component, every steps you can see here, how your AI agent is thinking and how it is generating the response. Okay. Now, this is the evaluator section, where you create evaluator. So there are a few default pre-built evaluators from Langsmith. You guys can use it based on your use cases. So you guys need to understand whether these pre-built evaluators are for end-to-end level or component level. So as I mentioned, for the RAG, we have answer relevance, groundness, and context relevance. So answer relevance is supported there, so I can just use it here. But for other two, I have to build it from the label data, or I can create it from scratch. So okay, I have less time. Okay. Let's first just show you how actually it evaluates. Okay. So I gave a prompt to the evaluator that, okay, this is your role, this is the instructions, this is how you need to score, and then what to assess, and this is the inputs. So I give evaluator that you will be given these inputs from the traces. You have to assess those inputs like this. These are the conditions, and based on that, you have to score, right? And then I am giving him the input from my traces. Feedback config is like one of the good practice that you ask your evaluator that this is the pattern that I want your feedback, so that it will not evaluate or degrade from the feedback. Let's say for evaluation. So see, I asked that, can you share about your pricing? And this is the docs. So this is my input to the evaluator. Okay, this is the query, this is the docs. Now this is the output. It says the retrieve policy doc directly answers the question by listing plan costs and features. The refund doc is also relevant to purchasing pricing items. The privacy doc is unrelated noise, but does not greatly detract from overall usefulness. So the context relevance is 0.95, and then this is the relevant evidence. Like evidence means from which, how actually it evaluates this. So this is, you can get the context relevance score, and then you will see this score in your dashboard in the feedback section. Relevant evidence, reasoning. So based on these feedback scores, you can set some alarms. Let's check you. Let's show you one more evaluator traces. So this is groundness. Groundness is to check whether my context relevance is actually related or not. So this is how it is giving me the outputs. This evaluator. The summary is 8 of 8 claims verified, no issues. So these are the claims, and then the evidence snippet means the claim that my agent is, a claim is the response, one of the response, and evidence snippet is if it is related to my retrieve docs or not, and reasoning is the way that evaluator reasoned to give it the supported status. So this claim is supported. So all of the claims are supported. That's why my groundness score is 1. That means the response of AI agent is actually from my retrieval docs. It's not extra or less. That's why all the claims are supported. So this is how you can evaluate your AI agents, and then you can send those these feedback keys. These are you can say it metrics. Each of it has the score. You can score it 0 to 1, 1 to 5, 10 to 100 based on your use cases. And then in the dashboard, you see the metrics. And then on those metrics, you can put alarms. And they have an integration with PagerDuty. So if say your AI agent is the context relevance is degrading, or your answer relevance is not good, or your groundness is not good, right? Anything you see anomaly over there, so it's gonna trigger your PagerDuty overview. You will get real-time notification. Oh, okay, my agent is not performing well. Let's see what happens. And then you come into this tool. You go to traces, evaluated traces, and then you see those traces. What is happening? So from there, now for the failed cases in the online evaluation, you have those examples. Later, you can use those use cases in your offline evaluation. So when then you go and you fix your AI agent, you test with your offline evaluation, you deploy in your production. So this becomes an evaluation lifecycle. So yeah, this was all about the demo. Yeah, that's all for today. Thanks everyone. Any questions? You guys have any question? Cool.
All right, moving on. So guys, I have an announcement. So Kubernetes has a community day event. This QR code will directly apply 10% discount, but it's first time first serve. So for first 20 tickets, it will be eligible for 10%. In case you guys don't see any discounts, feel free to insert the code below and then you get the discount ready and apply.
Okay, next.
Right. Time for a quiz. So, like what Rubin mentioned earlier, we will actually have prizes for the top 3 winners to win some Docker sweats. Right. So first question is actually from Kahoot. So feel free to log in and take part of the quiz.
Share and stream it. Yeah. Am I not sharing? Okay, it's good. Where the hell is it then? Hopefully this share.
Right, guys, in case you can't see, the pin is 3791164. We have quite a bit of joiners joining in apparently. Just know we're reserving the prizes for our top 3 winners. Right, guys, we'll start in about 10 seconds. So after 10 seconds, we will hit start and then the quiz will start rolling. Do keep in mind this is more of a more time based, so the faster you answer your questions, the higher you score. Alright, let's start. Alright, first question. It's a filling in. Everyone got the majority correct. One goes to yellow. Right, we have Danish in the lead. On to the next question. Right, majority of you got correct. Pumps and goals. Right, on to the next one. Finish, still taking the lead. This is a close one. Alright, sadly Danish lost the lead this time around. But guys team. Right, next question. Which best describes a spot strategy? Sadly, most of you guys almost got it correct, just 5%. Alright, now we have another guy in first place, Norman. Alright, on to the next question. What's the closest definition of famous? Slightly close this time. Alright, we made it back in first place again. Alright, that's a close one. It's from one of our earlier slides. Yellow takes the win. Alright, Jun Hong, first place, closely followed by Norman. Alright, this is a multi-selection question. What are the supported RDS types in AWS DB savings plan? Oh, this is a very close call. A majority of you guys got it right. Alright, Dean, again with the lead, closely followed by Jun Hong and Norman. Alright, for our eighth question, what's the runtime uncertainty in agent means? Oh, fantastic. Really, all of you guys got it correct. Alright, it's a close call, but Dean got the win. He stays in the lead. Alright, wonderful. Majority of y'all got it correct. Answer is blue. Alright, it's quite exciting. Now Norman's taking the lead. Alright guys, what's the source of truth in agent debugging shifts from code to? All right. Everyone got it correct. Nearly traces of actual behavior. Right, that was the last question. Now for on to our winners. Third place is Jun Hong. In second place, Din. Alright, now for our first place. Who would be? Oh, it's Norman. Alright, round of applause, guys. For the winners, you'll be receiving a prize from Dr. Kuala Lumpur. Alright, so the winners can maybe group up at the front, and then you can collect the prize.
Get a mic.
Alright, give me a minute. I'm going to pass the mic to Zidane.
I can we will take the six winners because we have players. The Kahoot player. The Super Swag, then we have also the different subscription for 1 year for the other 3 members. So the winner will be the first 3 with the Super Swag. The second 3 will be taking the what? Different subscription for 1 year. So any product from different like Gulan, Python, the other PHP Storm, any product, you can get it for free for 1 year, and that will be like a premium experience. So yeah, so please for this one. So this screen, please contact Robin. He will help you to get the code to claim the Docker swag. And for the other, where is this people? Where? Jeff? Excuse me? This is the Hoque. And what? Yep. So you guys.
Can I have all of you guys right in front here? Let's take a picture. Not all, basically the winner, sorry. So the winners, can we have on you guys on the stage? Not the stage, I mean the podium. So we have Norman, Din, Junhong, Hui, Jess, Yip. 6 of you guys. Yeah, okay. Let's take a picture first. That brain is handmade.
Take picture.
Yeah. So the person who got Dr. Flags, Norman, Dean, Junhong, say here. The JetBrains people can go to Zidane.
Yeah.
Alright,
You
cool.
can take the first event, you can take 1 year subscription of service.
Number 7.
You went to. Sorry, just send me. Yes.